Hello guys, today we are going to be looking at this topic of diffusion. Really important topic, really important that you understand it because it is a fundamental concept, which just means it's a really one of the core concepts when it comes to a couple of your sciences actually. So we're having a look at this in terms of a chemistry perspective. This will come up in your 7G particles topic, and you're going to have a look at how the particles spread out and move around through this process of diffusion. However, this does actually come up in your biology topic quite a lot as well when we talk about the movement of particles in and out of cells as well. So, as I said, it's a fundamental, really important that you've got a good understanding of it. So today, when we're going through this video, what I want us to know by the end of the video really is this second bit, explain how diffusion occurs, but also to be able to identify substances that diffuse into and out of cells as well. So that's just adding that little bit of biology on top of it as well. Okay, so if you have covered this topic in school already, the chances are you will have been asked at some point to close your eyes by a teacher. The teacher will have stood at the front of the lesson, they'll have sprayed some air freshener or some perfume or something, and then you'll have been asked to, with your eyes closed, put your hand up when you can smell the perfume or the deodorant. Okay? Eventually, what you will have found is this smell will have spread out throughout the whole room. So this happens in loads of different situations. It can happen if you're walking down the street and you walk past a really nice restaurant, you can smell the food cooking. Or maybe if you're upstairs in your bedroom and so whoever's at home is cooking dinner, you'll be able to smell it eventually upstairs. The reason for this, again, is diffusion. So we're going to have a little bit of a look at that. So why is it that smells spread out? This process happens in not just not just gases as we've talked about, but it does also happen in liquids as well. So it happens in anything that we call a fluid. You should have been looking at fluids previously in this topic. So the word fluid comes from this process of being able to flow. So when you've done your particle model at the beginning of this topic, you'll have looked at the fact that liquids and gases are both states of matter that can flow because the particles aren't quite as strongly held together. They don't have as strong forces of attraction, and therefore the particles can move around, and so they can both flow. So they can both diffuse. So let's have a little bit more of a think about diffusion then. So I've got a couple of particle diagrams on here, and I've chose to use particle diagrams so that it matches the rest of this topic. So as I've said, this topic you will have looked at how to draw the perfect particle diagrams for solids, liquids and gases. So you should be able to look at both these diagrams, left and right, and recognise that both of them are showing gas particles. They've got this random arrangement. The particles aren't touching. Particles are the same shape and size. So that's the criteria we look for when drawing particle diagrams. But this time they're a little bit different because we have got two different colour of particles. So as you can see, we've got the red particles and we've got the orange particles. What these particles are representing are something being sprayed into a room. Okay, so let's stick with this example of perfume or aftershave or deodorant. They all work in the same way. I'm just going to keep saying perfume. So at the start, what this is representing is in this area here where you can see my mouse, this is where the perfume would be being sprayed. The red particles are representing perfume particles. The orange particles are representing air particles that are already in the room. So what you can see is at the start of this process, before diffusion has happened, we've got a really high concentration of the red perfume particles. So by high concentration, I just mean there's lots of them all in one place. Throughout the rest of the room, or throughout the rest of the air particles, you can see that I've got a really low concentration of the red perfume particles. Okay? By the end of this process, so we're now looking at the right-hand diagram, you can see that these red perfume particles have spread out evenly in amongst the air particles. This is the process of diffusion. So by definition, diffusion is the spreading out of particles from an area of high to an area of low concentration in a fluid. So this is the perfume spreading out through the room. It would work the same if you thought about having a bottle of water and then pouring some diluted juice into the top of the bottle of water. The juice doesn't just stay at the top. If you leave it and don't touch it, eventually that juice will spread out throughout all of the water. Okay. Oops, sorry, I didn't mean to go on there. Okay, so this is just that definition there, as I've said. So diffusion is the gradual movement of particles from a place where there is lots of them, high concentration, to a place where there's fewer of them, which is lower concentration, and it occurs in liquids and gases. So this random movement, this gradual movement, is also due to a process called Brownian motion, which you should have learned about in the lesson before diffusion. So this is where particles do move around randomly because they're bombarded with either air particles or some kind of fluid particles making them move around. Okay. There is a link on this slide as well if you wanted to read a little bit more about it. The link takes you to BBC Bite Size, and that does give you a bit more information on diffusion. So I've got the same diagram on here again, just from a different angle, just to show you that spreading out. Again, this is a different diagram, and this one just incorporates a little bit of extra knowledge there because it shows you this process in the middle as well. So what we've got at the top is we could maybe think of these this time as diluted juice and water, where the blue particles are diluted juice particles and the red particles are water. As you can see in the beginning, there's a barrier between these two particles, so I haven't poured my diluted juice into my water yet, for example. So when I remove the barrier, so for example, I'll pour that diluted juice into the water, what you can see is straight away, these diluted juice particles start moving from an area of high concentration where there's lots of them and start spreading out to where there is a lower concentration of them, fewer of them. This red line just shows you that random movement of the particles through Brownian motion as they are spreading out through the fluid. By the end, as you can see at the bottom, what we've got is an even spread where these blue diluted juice particles are evenly distributed amongst all of the water. Okay. You might have seen this in class. A teacher might have shown you this using something called potassium permanganate in water. It's exactly the same process. If you drop some potassium permanganate into water, it's a purple solid, crushed up. It looks like a shiny, looks kind of like a shiny little rock, I suppose. That's what it looks like. Because it's heavier or more dense than water, it drops straight to the bottom. But as you can see, through time, it doesn't remain at the bottom. That purple colour diffuses or spreads out through all of the water. There's a really key question on the side here as well on the PowerPoint. How could this experiment be altered to see if increasing the temperature increases the speed of diffusion? So this is another concept that you will have looked at in class because temperature does affect the rate of diffusion. So what happens is if you increase the temperature, rate of diffusion will also increase. And the way that I like to think of this is if you think about making a cup of tea, if anybody's ever made a cup of tea, I've done this before, where you've thought you've boiled the kettle, but you haven't, and you pour some cold water into your cup on top of your tea bag, what you'll notice is that tea doesn't spread out, it doesn't diffuse very easily in the water. However, if you boil the kettle and then put that onto the tea bag, you'll notice that tea diffuses a lot more easily. So higher temperature means diffusion happens more quickly. Finally, I just wanted to go through a couple of different things that are transported in and out of cells through the process of diffusion. So things like oxygen and glucose, both of which are really important to get into our cells so that our cells can respire and provide us with energy. But also water and carbon dioxide also diffuse into and out of cells via the bloodstream as well. Okay, I hope that was helpful. Thank you very much.